So, welcome back, Brian. So you were presenting to us yesterday, weren't you? And glad to have you back today. And welcome everybody, by the way. Sorry. Oh yes, we've got viewers now. So welcome back to all of our attendees. So this is session 8Q. And just a quick recap on feedback, if you haven't done that already for your previous session that you attended, don't forget to do that. Before Brian starts, just a little reminder, you can post questions in the chat. We'll read those out at a convenient moment. And also you have the possibility to unmute your line at a convenient moment. If you want to stop Brian and just ask a question, feel free to, to unmute your line and do that. But without further ado, welcome back, Brian, and talking to us about a very thorny topic, I would say, around APF, as I gave you an example of earlier on. Some sites out there aren't doing a very good job of securing them. So over to you, sir. Thank you.
Okay, thank you very much, Jamie, and great to be back here at the GC UK today. So yesterday we talked about an offering that isn't even available yet, and now today I get to talk about something that's been around for quite some time in the land of ZOS. My name is Brian Childs, Principal Product Manager in ZOS Security here from IBM, and the title of our topic here is Defending the APF, Methods New and Old. For those that don't know me or haven't seen me present recently, I like to credit all the fine friends, colleagues from IBM Security who help me understand different things, and I like to give them kudos for the various topics of their expertise. And they let me make cartoon avatar cards for them. So here are the SMEs that we're going to hear from today. And it even includes SDSM RACF SME Mark Nelson, who is on the call today to help me whenever any of those thorny questions might come up. So we'll see how we progress. But let's step back, as we are talking about fundamentals, and have that quintessential question, the APF, why is it so important? So I went back and found this excerpt from some IBM documentation for starting up education for ZOS from ZOS Basic Skills. And I'll just read out this partial quote real quick. An authorized program can do virtually anything that it wants. It is essentially an extension of the operating system. It can modify system control blocks. It can turn off logging to cover its tracks. Clearly, this authorization must be given out sparingly and monitored carefully, end quote. So there you have it. In a nutshell, the importance of looking at the authorized program facility and the associated authorized programs within it. And here is the link if you want to go to that full document of ZOS Basic Skills. So next up, we are going to get some insights from Mark Nelson, or RACF SME. What does authorization really mean? There is a little bit of ambiguity sometimes, depending on the context. There is authorization from a Z architecture perspective, and then there's authorization, let's say, from a RACF or external security manager perspective. So we'll go over some other fundamentals of that now. So first off, there's this program status word, the PSW, of all its fame and glory of the Z architecture. This is a special purpose register for the CPU on Z, documented by the Z architecture principles operation, and contains information for execution of the currently active program. All right, so what relationship does this have to what authorized means? An executing program of a task is considered authorized when it runs in supervisor state, which is this bit 15 of the PSW, or it runs with a PSW key in the range of 0 through 7, which are bits 8 through 11 of said PSW, or, and we're kind of crossing this dotted line here, all prior programs executed from this task were APF programs. So the authorized program facility is this subset of programs within your ZOS environment. And so if they have been linked a certain way and put into this library and protected in various way, you have this notion that they are authorized simply because they came from that library. So if any of these three aspects are true, then it's considered authorized. But there's also this nature of SAF-RACF authorization, and it applies to access to these associated APF load libraries, and then SAF-RACF checks within those APF programs. And then also when you're talking about authentication of users to access any of the associated resources, right? So basically you've got it for authorization from the Z architecture. And then to a large extent, the APF is this tight boundary because it's RACF that's going to protect the access to those load libraries, but it also gives you the ability to give very granular access controls to all kinds of resources across ZOS and the associated applications. So sometimes when people talk about RACF authorization, they're talking about very specific granular resources. But when we're talking about the APF, a lot of times, once you get past the access to the libraries themselves, you're talking about authorization from an architectural perspective. Okay, so further clarification and just fundamentals of architecture here, because I know there's all kinds of excitement around quantum safe encryption as a journey, and the Z16 being proclaimed the first quantum safe system. But just to make sure we're completely clear, the PSW key is not a crypto key. It's not about encryption. So way back in the beginnings of the creation of the architecture, because we're even going back to 24-bit virtual memory now, each virtual page could be 24, 31-bit, or even in the case of 64-bit that came later, a memory object. Each of these entities has a storage protection key. It has an attribute of being fetch protected or not, and it has an attribute of being store protected or not. Right? So we're talking about designating this portion of memory and whether you're typically able to be able to view the contents of that memory or to update the contents of that memory. Now, a program's execution key is matched against that storage key. If it's fetch protected, the memory can be read if the keys match. If it's store protected, the memory can be updated if the keys match. And then, special note, a PSW key of 0 matches all 16 keys. So furthermore, any authorized program, we talked about those attributes before, whether it's supervisor state or from the APF load library chain or PSW key of 0 through 7, any authorized program can transition to PSW key 0. So in other words, from an architectural perspective, if it's authorized, any of these programs can view virtually any memory and update virtually any memory. So going back to that initial overview from the basics of ZOS, APF programs are extremely powerful. They can do virtually anything because they can transition to this extremely powerful PSW execution key, and they can do basically whatever they want with the memory on the system. So important review as we go into the corresponding protection mechanisms. So let's say, at a very high level, we're building up security into some ZOS application. So let's consider this theoretical ZOS application we'll call XYZ. So let's have it linked AC1 and have it reside within the APF library. Let's say this general purpose application has functions for add, change, delete list of its XYZ resources, whatever they might be. And then it also implements these functions with SAF-RACF calls to restrict the access. So in other words, XYZ, because it's coming out of the APF load lib and linked AC1, so it can be directly invoked this way, fully authorized, can do just about anything. But it's going to provide these very granular resource services and use the external security manager to provide granular access to those resources. So an application that now goes in and requests those services, it doesn't need to be architecturally authorized. It just needs to be authorized to those very specific resources. So let's consider this other theoretical and this time unauthorized program, ABC. Again, XYZ can do just about anything. It's considered an extension of the ZOS operating system. Unauthorized program ABC cannot. Program ABC can invoke these functions via the SAF RACF access under the associated user ID in which it is running. So that's a super high level view. It talks about the building blocks of programs on ZOS, where you have this critical footprint of the APF load libs, the programs that can do virtually anything, and then other programs that can run unauthorized and get selective RACF access to do selective things. Okay, so then you asked the question, and we're going to get some insights now from Marna Wally, SDSM ZOS install architect, because it begs the question, well, where are these APF libraries? Like, how do you designate this on the IPL where these things are going to reside? So in other words, location, location, location. APF authorized programs can actually reside in many places. And given how powerful they are, you really have to have a really good sense of your complete list. So they certainly reside out of sys1.linklib, sys1.svclib, and sys1.lpa-lib. Any other module in the link pack area also counts. So that's FLPA, PLPA, and MLPA. And in addition, any module in the linked list concat when link auth equals linked list. So including your whole linked list concat on top of what we just mentioned can be a lot. And note very specifically here that link auth equals linked list is the default. So by default, your linked list concat also counts as being part of the APF load lib. The following modules when link auth is APF tab is sys1.moglib, sys1.css-lib, sys1.siealnkey, and sys1.sieamige. So good to have a sense of what your list looks like. But in addition to all these we just talked about, any authorized library specified by the installation, static or dynamic. So there's so many possibilities. We have to flow into another slide. So we'll do that now. So the APF can change from a dynamic perspective via setprog and setprog. And yes, they sound very, very similar, but those technically are two separate commands with separate RACF controls around them. So there is the ability for compatibility across the decades for static installation specified APF via IEA APFXX. That is not recommended. The corresponding opera commands, class profiles to control setprog and setprog are listed here. All the, that little period makes all the difference, the extra one. And then there are these corresponding facility class profiles of CSV APF, whether it's the live name, whether it's setting MVS setprog format to dynamic or to static. And then we have a special additional note here from Catherine Voss at the IBM-Z Center for Secure Engineering to note the special purpose and very important functionality of the CSV APF exists health check, right? Because you want to know about this. There's this potential system integrity risk when a data set cannot be allocated using the criteria specified in the system APF list. Right, so what you want to be double checking here, again, you want to know the full set of all your APF load modules. You want the whole list of these load libs, but you want to make sure if they've got an entry that there is an allocatable data set out of that entry. Because if there's a spot that's not, then a threat actor could come in, create whatever program they wanted, and basically insert it in that empty spot. Right, so that's something to look out for as well. Okay, so we're gonna get some more assistance here from Mark. We're going to reference the first and I think Mark's all-time favorite RACF ZOS health check. none other than RACF sensitive resources. And this report, super helpful. It's continued to expand over time, goes over all kinds of resources that you want to double check. You have really tight security controls over. And by no small coincidence, the APF dataset report is the first category that is listed. So here we have an extreme example, and hopefully this is not the case for any of your systems out there, but something that you just want to double check. The E on the left-hand column shows that this is an exception, and you say, why is this an exception? Here we have this hypothetical dataset of sys1.muslink that is listed as part of the APF, and it has a UAC of update. So what does that mean? So we've talked a bit now about the nature of the APF load lives, their corresponding programs, being able to do virtually anything. So powerful, you can consider them an extension of the operating system. And so in this case, you basically said, any user on this z/OS production system has the ability to put a program of their choosing into this load live, a program that can do anything. So basically, this really circumvents your whole security posture on this production system having this in place. So you want to double check that that is not the case on any of your systems after you've gone through and seen the full list of where your APF exists. Okay, so on this next slide, and not only are we getting insight from Mark, but we're going to give a shout out to Bruce Wells, who is a product owner for RACF development. You will see on the bottom portion of this slide, we have a link to our Enterprise Knights user group out in the IBM Z and Linux One community. So just a public posting of various security practices and guidelines. He had a 4-part mini-series he put out not too long ago on recommendations on securing USS. So the context of our APF topic today, sure, you have double-checked that you have locked down the APF, let's say, in the traditional way and traditional MVS z/OS style. But let's not forget USS. So one thing that was done when USS was implemented is close to 25 years ago now. But because it's fully compliant with the POSIX standard, we decided that we needed more security controls added in addition to that standard. And for the most part, that came in the form of facility class profiles whose entity names begin with BPX. And so here, this is an extension of the same sensitive resources health check from RACF, and it goes over a bunch of these entity names and sees what they look like. Now, these are very special purpose profiles, and their accesses work a little bit differently. They're the type where the difference between none and read is like a switch. Whether something is do you have the ability to do a thing or not? Now, specifically, we're calling out this exception. It's another really nasty one. If you've got UAC of read to bpx.fileadder.apf, that means basically any user on the system has the ability to designate one of their programs running out of the shell to be part of the APF. So in other words, again, they have the ability out of the shell to run a program that can do virtually anything. As in the general sense, when you're looking to lock down access to resources, you do want to make sure that you have lockdown resources through USS as well, and specifically to the APF. That is a specific entity name that you want to take a look at. Okay, so there, that's kind of our overview of utilizing the z/OS health check that has been there for quite some time, and then double checking with regard to access to the APF load lives. Okay, I'm going to switch gears, and we're going to have a little creative segue here. And you may notice a theme with just about any presentation that I'm going to do on security. I'm going to find some way to insert the important topic of MFA, simply because if your authentication is going to be reliant upon something like 8-character passwords from many decades ago, there was a long-standing risk to social engineering attacks in various forms that that presents a lot of upfront risk. So if you're looking to protect the APF, you also have to protect the authentication of any user ID that is going to have access to the APF. Let's say, for example, it's a small set of lead sysprogs that have the ability to update the very sensitive library. How do they verify their identity at logon? So there's that. So that's a good insight from Ross Cooper, RACAP-SME, who has done all kinds of design and development over the years for authentication and the various SAF prerequisites for MFA. Okay, all right, done with that MFA plug. And now we shall go in to this other topic. And we're kind of flying through the slides here, and please do interrupt with any kind of questions, feedback you may have. We're looking at the APF protections in a rather holistic manner today. A lot of this stuff is fundamentals that has been in place for decades. Now we're switching gears slightly to some functionality that is a little bit more recent in the history of ZOS. We're going to talk about file integrity monitoring and change tracking. So we get some insights from Marna Wally again, as well as Hans Schoen, longtime Z security architect for Z. So points to ponder, because we're talking about APF in the context of these load libraries. What kind of change control process do you have in general for anybody updating programs on your production system? Do you have additional change controls for when you are making updates to the APF, or at least as strong as everything else? Do you know exactly who, when, and where any update to the APF is going to be made? Whether it's from your own custom code, whether it's code from IBM, whether it's code from any vendor, whether it's some significant enhancement or just even the application of PTFs for some bug fix. Do you have a full grasp of what's the current state of your APF load lib collection, and do you know specifically when something changes, right? So there can be like a manual process, but then this other question: are there programmatic discovery notifications around modification to the APF? So IBM has some offerings here. The ecosystem has some other offerings. So it's something very worthwhile to look from your system management overall, but with this very specific security context, given how powerful the APF really is. Do you have configuration management records of the specific user ID and times around any modification to any APF load module? And do you have backup procedures for restoring earlier versions of APF libraries as needed? So, these are, of course, theoretical questions. I'm not expecting any kind of response on this recorded call, but they're very sensitive questions because you really want to have a really tight handle on the change controls on these extremely powerful programs. Okay, so from here, I'm going to switch gears, and we're going to talk a little bit about integrity and the importance of integrity to APF programs in particular. So far, we've gone through at a high level what the APF is, what authorized means from an architectural perspective, and then the importance of putting tight security controls around the load libraries in which they're designated, how you specify, what load libraries they're going to be, and then the change control management that says, okay, well, as I'm going to monitor any kind of change on my production system, the APF is something that I really want to have uber focus on. But that says nothing about system integrity per se, right? Up until now, we've said, well you're kind of going with the assumption that the foundation of integrity on this code is solid. So in considering the various tenets of cybersecurity, you want to include that integrity facet. So here's an example let's say we're doing some kind of API from one of these APF programs. Let's say it's, for example, from IBM, and one of the developers puts in this particular processing of a parameter list going into a program call, a PC. And they're doing a load address of general register 3 from some output parameter area, and then move character instruction using that trusted base address that you just put into register 3 and throwing it to and using a register 2 as this reference point. So somewhere, as the result of processing, we look back to that example of all powerful program XYZ, and maybe providing some service update to X to what is it with ABC. Then ABC is not running with a whole lot of authority, but is now providing this parameter list to get some output. Well, the thing is, you can't trust that unauthorized program, that unauthorized user. You have to consider the possibility that there could be a threat actor trying to get to escalated privilege using this API. And what is the fallout from this when you are potentially updating an output area in an API of a program that is likely running supervisor state key 0? So as we talked before, execution key 0, you can update virtually any memory. So let's take that consideration of a threat actor experimenting on this API to see if it was written with integrity, and then find out that, oh, it's allowing an unauthorized user to come in and then update a system control block because the threat actor just passed in this output data pointing to a system control block. What is the risk there? Well, the risk is that the threat actor has potentially tricked this API into this all-powerful program to mess with that system control block, and you run the risk of compromising your security posture. Right. So now, are we thinking everyone's going to just learn all kinds of assembler and go and fix all this code? No, we'll get into how you can scan for such things and how you service these things. But this is just for purposes of example, the importance of looking at the integrity of these interfaces within APF load modules, and from wherever they come from. So if you want an example on the assembler side of what's good, is you basically, inside of implementing these interfaces, you can't trust the caller. So you can't do a move in your current execution key, which is probably 0. You have to use specially architected instructions using the caller's key. Right? And by default, the vast majority of the Z architecture instructions run with the execution key. That's what it's for. But in the case of this very sensitive boundary of an authorized program processing an unauthorized program's request, here, this is a specific example on the bottom, MVCDK is move with destination key, meaning I've got the key of the caller, and I'm going to make that move in that context. And I've, in the preceding instructions, I have extracted the caller's key from the linkage stack. So I am trusting nothing. It is from the system itself. So I know that is the key of the caller who invoked my interface. And now I'm doing the move destination key wise in that context. And if the caller pointed this output area to some system control block that they do not have any authorization to, then this MVCDK will blow up. And so that append will preserve system integrity. All right, so that's like a very specific assembler example of why integrity is important to the interfaces of the APF. And so now let's see if what do you do about that? So for starters, we can it's been over 50 years since IBM made that initial commitment to integrity on the mainframe. And since then, it has expanded greatly to the various operating systems that run on Z. you can get more information from this link here. So here, getting some insights from Peter Spera, SDSM at the IBM Z Center for Secure Engineering. IBM utilizes internal and external sources to uncover potential vulnerabilities. And this example we just covered with potential vulnerabilities within an APF program, is a subset of that scope with regard to ZOS and the things that the secure engineering team will look for, and then if things are confirmed, would send out patches. So the next question is, well, how does the customer know about that? And many on this call are probably already familiar, but IBM Z offers this security portal and allows clients to stay informed about patch data, associated common vulnerability scoring system, or CVSS ratings for new APARs and security notices to address these highly publicized security concerns. Now, from here, you're saying, okay, so this is one aspect of which IBM, the security engineering team, and the extended development team is looking for, and will patch as things are discovered. But then once this second PTF comes out, how quickly do you apply it to your system? So ironically, we're on slide 16 for a slide that's titled First Things First. So that irony is not lost on me. But this is just a quick review of the Common Vulnerability Scoring System, or CVSS. IBM did not make this up. This is certainly not specific to Z either. So you can look at this link, www.first.org. And the scoring system goes from 0.1 all the way up to 10. So low, medium, high, critical. And this scoring, first.org has the full mechanics of how you calculate the numbers, but they're based on exploitability metrics and impacts. So it's a question of, what does the attack vector look like? What does the attack complexity look like? Are there privileges required? Is there user interaction required? And then to these fundamental tenets of your security posture, is there a potential impact to confidentiality or integrity and or availability? And you put all these things together and you get this score. So you may be wondering, from an APF interface perspective, what typical scores might you be looking at? Well, if you think of the possibility of an unauthorized program being able to look at virtual memory that they shouldn't be able to look at, well, that's really, at least at some scale, data breach territory, and it's going to come around a 6.5 out of 10. And in a more severe situation, if you've got a potential vulnerability where you could potentially be updating system control blocks, in the example we saw before, well, what if you could go in and update the control blocks associated with your security posture? So that could be as high as an 8.8. So a very, very high level. And the only difference really between an 8.8 and a 10 is that you still need a user ID on the system in order to attempt to make an exploit out of that. So again, we're talking about vulnerabilities versus exploits, but the notion is to be having this due diligence and getting the second PTFs with the information in front of you to say, here is the relative severity, and then determine your business choice as to how fast you apply that patch across your production systems. Okay, so here we're going to hear from Diane Stamboni, Integrity SME. She's a product owner of Zax, which on the IBM side is our authorized code scanning feature. There is also another scanner that is available from KRI, which was not so long ago acquired by Rocket Software. Those are the only two that I know of. If there are more, people can clarify. But in both situations, we're talking about ZOS-specific scanning that really focuses on the APF load libraries. So I mentioned this a little bit yesterday in the context of our anti-malware discussion of what anti-malware is not. But in terms of your security posture and the importance of integrity as the foundation to everything, this kind of scanning specific to ZOS, mitigates a solid attack vector in that you could have potential vulnerabilities from a variety of places. Yes, IBM has had this long commitment and will send you these second PTF patches through the security portal, but you can also have APF programs coming from anywhere from the z/OS ecosystem, and over the decades, you may very well have quite a bit of APF that you've built your own in-house that is specific to your enterprise. So when you're talking about how integrity scanning is done, it really comes down to, well, what kind of interfaces do you have out of these APF load mods? So first and foremost, you think about program calls and supervisor calls. This is really the fundamental building blocks of basically the z/OS solution stack, right? These are very, very much the primary APIs of these programs. And as we mentioned this specific example, their implementation is really critical to the integrity of the stack. Also, it's important to note, and we mentioned briefly this denotation of a load module being linked AC1. What's the difference, right? What's so special about an APF module being linked to AC1? It's that nuance makes it possible for you to invoke that APF module directly, right? So in other words, you can invoke it out of batch processing. You can also invoke it out of the USS shell. And so does your scanning capability include that as well in terms of looking at the possibilities of interfacing with these very powerful programs and looking for potential vulnerabilities that you could have patched up before they might be theoretically exploited. So that's kind of the significance of the APIs and the significance of scanning. And it's not through other types of scanners. As you go higher up in the stack, let's say from a web application perspective, web app scanning is certainly very valuable. Source code scanning of Java and other high-level languages also very useful, but it's very much a scanning special purpose for z/OS to the foundation of what we have as the APF.
Brian,
Okay.
can I just sorry, a question for you, if that's okay?
Sure.
So that term unauthorized callers, that trips up, I think, some security people, especially those that are used to looking, like in Z-Secure, for example, looking at the SVC and the PC type audit reports that show up issues, and you see it like in bright yellow, caller may be unauthorized. And I was having a conversation with a security person, they're saying, oh, does that mean then that they can't, they're not RACF authorized? Do you know what I mean?
Yes.
So you want just to clarify, so people no doubt what that term really means.
Yes, absolutely. Thanks, Jamie. And it circles back to the early part of the presentation, because there can be some ambiguity of what is the context when you mean unauthorized, right? And in this context, unauthorized, it still presumes that you have been validated, your authentication to RACF, to any ESM for z/OS. Like, you are logged on to the system, and you may have RACF access to a variety of data sets and other general resources, but it also means that you do not have an architectural level of authorization, meaning you are not associated with programs that can do anything. So this is making sure, on an integrity perspective, for APF load modules, that quote unquote unauthorized user can now become fully authorized to be able to do anything. And hopefully that helps clarify things. Much of the point of an ESM in z/OS is to fulfill or at least pursue this nature of least access privilege. RACF and other ESMs provide very granular access controls and logging capabilities to all sorts of resources. So you will get access to exactly what you need to be able to access, and hopefully nothing more. When we're talking about the integrity scanning to make sure that someone doesn't become fully authorized in the architectural sense, it's meaning, let's prevent a user ID from from elevating their privilege to the point that they can access and do anything on the system. That is the extreme.
So that the calling program then is like, so is not authorized, not APF authorized, but it needs to call something that is APF authorized to do some very privileged functions. So at that point, then the control is passed then to the authorized program, and that's where that validation check needs to be done, isn't it? In that code, is that correct? So that we're not making sure the unauthorized user is not doing stuff that that they shouldn't be able to, but ultimately they can get get what they need to get done through the authorized program that's making sure, okay, yes, this user needs to be able to do this, but they can't do dangerous things.
Yes, exactly right. When someone, let's say a vendor or in-house, someone is designing their own APF program, this program that can do anything, then it is quite likely that that program is designed to provide very granular access controls to certain sets of resources under these very specific conditions. But the way in which they implement those specific services is probably through PCs and SVCs, and they need to implement them carefully with integrity so that they only are granting access to those specific resources.
Thank you, Brian.
Absolutely. Thank you. Okay, so I think we have maybe one slide left. And continuing this notion of mitigating the risk of elevated privilege, mitigating risk of updating system control blocks, and thinking from a potential threat actor's perspective, if you could choose, let's say, the first control block that comes to mind that would be that you would use as a hacking perspective, the ACE is probably near the top of that list. So RACF some time ago did put out functionality called ACE modification detection. Now, we do need to clarify that if you reach to a point where a threat actor is able to elevate their privilege to full architectural authorization, right, for a user ID and associated program to be running supervisor state key 0, then mitigations that follow cannot be foolproof, right? Because that is already into a very serious situation. But this does give some level of mitigation to potentially catch such a thing after it would occur. So to that end, what we have optionally through the ACE check class, there's you would activate the class, and it will determine in various scenarios whether your ACE environment has been updated with regard to a certain subset of very critical attributes. So there's this new RACF message, IRR 421I, issued when a privilege escalation is detected, and you can see the details here. And there is this notion of exception processing. So if you go through and determine that there are times where authorized programs will be updating ACEs on purpose, that it's not a threat actor situation. It might not be considered like ideal implementation all the time, but the functionality does include this way to define ACE checks exclusion process for these different scenarios, these different examples. And as you get further along and you've tested this on your environment for some time, that you've identified let's say the known false positives and put them in as the exceptions, you can set up this functionality to append on failure. So in the ACE check class, if you've got IRR.append on failure defined, then you have this append code of 4Charlie6 when this ACE privilege escalation is detected. So certainly wouldn't start with the append on failure, but it is something well worth looking at for RACF clients as this extra level of mitigation, looking for this possible privilege escalation. So again, you're talking about kind of like the intersection of RACF and its processing of RACF specific authorization, but this whole underlying foundation and integrity of the APF load libraries, that if somehow there was some kind of vulnerability that had not been patched, that a threat actor gets in and then goes and starts to update the ACE is one of these critical control blocks, you have this additional mitigation and chance to be able to find that and take action.
So Brian, if you, in your previous example, if you'd got the bad version of the code, where it just kind of updates a control block that it's been passed without doing any MVC decay, would this ACE modification detection actually pick up on that? Or is that separate?
Okay, that's a good question. I would say that they're related, so I'll give a couple clarifications. When, let's say you've got one of these examples in a PC or SVC where an MVC decay was not used. Let's say you have a CVSS score of 8.8, like sitting on a production system. It's at this point in time in this example, it is just a vulnerability, right? It would take a threat actor's exploit in order to utilize that vulnerability, to leverage that vulnerability, to then subsequently start messing with control blocks. So if the vulnerability is there, if the threat actor found it and then created exploit code to go and update, let's say, an ACE, then this mitigation could take effect under certain conditions. I'm just saying that because of the fact that if you get to that level of privilege with a user ID and program of supervisor state key 0, then there are going to be certain cases that are not necessarily easily mitigated, but this mitigates some. So it is definitely related. It gives you an extra chance with regard to detecting an active exploit on your RACF control blocks. Does that help answer the question?
I think so. So it would pick up the exploit potentially.
It could potentially pick up an exploit in process, and is most certainly recommended to patch said vulnerabilities right up front.
But of course, yeah.
Yes, of course. But this is an added piece of function for RACF that is certainly recommended to turn on in your systems, but only in warning failure until you've gone through a potential list of false positives, because it's to some extent there is maybe it's a style of programming for various authorized programs that deliberately update the ACE from time to time, and you want to identify those up front, and then as that gets further along, then you can turn the abend on failure option on.
Can you selectively turn the abend on failure so that you have a white list of programs that it's part of the programming style that they do this, but if it's anybody else or anything else, then yeah, you want the to abend. Or is it binary?
I think it's abend on failure for anything that is not in the exclusion list.
Okay, so you can have an exclusion list. That's good.
Yes, absolutely do support an exclusion list. Okay, great questions. So we have reached the thank you slide. So I will say thank you again for letting me be part of the GSE UK virtual event this week. And we have a couple questions yet, or time for questions rather. I'll go through my trademark slide. And make sure you do include the session feedback for Jamie and Sue, and let us know what you think of this session. But yeah, we have a couple minutes if other people have other kinds of questions with regards to the APF or other security topics.
Thank you so much, Brian. Yeah, so folks, so yeah, we've actually got 10 minutes until till the end of the session. So yeah, any questions? You can unmute your line if you like. Don't be shy. If you want a question, if you're sitting there dying to ask a question to Brian, then you know, don't be afraid. Unmute or just post your question in the chat. Just while we're if anybody has just to give people a moment to think about that. So, Brian, I was just as you were going through that, and thank you for that brilliant session, by the way. There's actually a lot to think about, isn't there, with regards to the protection of APF? I think there's this, like, there's a lot of emphasis put on, of course, access controls, to make sure that that they're locked down. But it's just so much more than that. I mean, you just described. I mean, it's like the whole check like the file integrity monitoring, side of it. So yeah, has it changed? Who's actually updating it? An inventory of what's approved in terms of like APF authorization, so like that change tracking, and it's just there's an awful lot to think about these days, isn't there?
Yes, and I would hope with regard to programmatic change management on anything getting, let's say, moved into production, that scrutiny on the APF has very special attention. I think that makes a whole lot of sense if you're considering whatever type of attack vector, like how well do you defend your ZOS security posture if a threat actor is going to come in, whether it's compromised through authentication, whether it's an insider threat, what have you. If there's a way for them to create an APF program, well, if that occurs, then the threat actor has a program that can do virtually anything. So it makes total sense that you would have all kinds of file integrity monitoring, so you have a very close, tight scope of every aspect of your APF, right? So to have the full list of where all of it is, and corresponding lockdown of anybody who has the APF authorization through the USS shell. But then when any kind of APF update is made, to have that set of checks, like, okay, this is S&P installed PTF patch from vendor so and so, or from our dev team, or from wherever, so that you know where all these updates are coming from. They're planned for, and so that if you ever see a delta that is unplanned, or an APF program that you have never seen before, and it just appeared in one of these load libraries on the fly, then that it's probably quite prudent to give that extra diagnosis and attention. And then once you've got that level of scrutiny on management of the APF itself, then you do have this segue into serviceability and potential integrity vulnerabilities that you want to look at scanning and patching. So it's kind of a multi-step process.
Yes, indeed. And apologies, I just got prompted that I was apparently quite quiet when my audio wasn't coming across very well, but hopefully you can hear me better now. But no, thank you for that. I don't want to hog, because I've got a couple more points actually I want to say, but any additional questions from anybody in the audience? No? Okay, yeah, a couple of points. The health checks, by the way, I love that you referenced those. As Mark Nelson knows, he knows I love those health checks. I did talk about those in my February session, actually, about how important they are to review. And because I was saying to people in that session that I was setting up a new RACF database from scratch. And the health checks were actually really good, because at the time I didn't have like a Z-Secure or Vanguard installed, so it was like very early days. And but I was so thankful that those health checks there. But even when you've got a product, like security product, I think it's so important to check those, particularly like those APF ones. The one that you said about that the APF exists test, where you've got like stuff in the APF list, but they're not actually defined on disk anywhere. That's a kind of potentially a major issue, isn't it, in the future?
Yes, yes, indeed.
an area that is often overlooked, where you've got software that's been uninstalled, things have moved on, and someone's just not gone behind the scenes and done the hygiene, side of it.
Right. Yeah, you don't necessarily, are not necessarily cognizant of the weak point that you may have inserted if you do half your cleanup. if
Indeed.
if the program is removed, but the spot in your APF list remains, then you have created an insertion point that someone doesn't need to have access to the APF load libs themselves, because that name exists, and they can create a program under that name. So it's an important gotcha that the health checks help with. Right. And in general, go ahead.
Yeah, I think the reason that it is so underknown. This is the question of an APF data set in APF list when it doesn't exist.
Yes.
So the question is, what authority is needed to actually create a data set of a particular name, potentially on a particular device? And I when we were doing that health check, the RACF sensitive resources health check, we had a long discussion with some very, very smart folks who knew the ins and outs of lots of parts of the operating system. And we found 15 different privileges that would allow you to create a data set of a particular name in a particular place. And at that point, we stopped counting. And the reason why the list is as large as it is that we have storage administrators who have the ability to do things like move a data set from one place to another or recover a data set. And some of those privileges allowed the specification of the target location. So they're privileges that you might not consider, but if you have the way we sometimes look at it is if you have slices of Swiss cheese with holes and the holes are lining up, if you have a hole through 3 slices, you have a vulnerability. So,
indeed.
Yes. Thank you, Mark. Yes, it is kind of one of those nuances. Like if the entry is there, then the typical access controls are in full force. But if you say that an entry is there and it's really not, then there are these historic functionalities like through the storage admin that allows someone to place something in there that you might not expect they could.
Indeed. A couple of other points I'll make. So we were talking about those stories that I told you just before we came on air. So there was last year I found a production system where it was managed by a third party IT company, and it wasn't a RACF system. It was another ESM, shall we say, and the one of their APF authorized libraries, which is really, really old, that had the equivalent of universal access of Alter on it. So it's kind of, and they had like alerting and stuff in place, to detect if like new UACs and stuff were activated. And they had this whole checklist of things to look, but something failed somewhere along the lines where their security checks missed that, and apparently that issue had been resident on the system for a very long time. So I think the overriding thing that I took from that is don't just rely on your kind of current security, like the alerting and stuff that goes on to detect new things. It's also, you've got to look back, haven't you, and say, and do spot checks and things, and do your daily reporting to say, do we have any new exposures here with regards to the protection of these? Is right. One thing.
Yeah. Exactly, and that's really that general concept is kind of the reason why we felt that a session like this, just largely going over the fundamentals, are important, just to make sure we reiterated the various aspects, because the APF and the integrity of the APF is really the foundation for your whole security posture on your production system. So looking at those facets is really fundamental to everything else that you're going to do as the security admin or the sysproc.
Indeed. And one final point I will make, and sorry, I did mention this in February and at the November conference, but I'm so passionate about this particular topic, especially around the ACE check feature functionality that was introduced.
Yes.
I just, to everybody on this call, if you're managing to get that activated as soon as you can, because I switched it on last year, I think it was, It came for this same company where the third party was managing the whole ZOS infrastructure, and that detected a system programmer actually elevating their privileges, through the magic codes, the switch to the modifying the control block to give themselves system special, because they were trying to fix an emergency situation because of a ZOS upgrade. So that actually, in partnership with Z Secure Alerting, picked that up, and when we found out about it, and the guy admitted, that he was under pressure to bypass, to get the job done, to get the system up, because there were implications if it wasn't done. So yeah, if there's any incentive to get this switched on, that's probably one case. Don't believe that it doesn't go on, these things, but they absolutely do. If people are under pressure, they'll try and cut corners, unfortunately. So, sorry, I know I've hogged the last 10 minutes.
Sorry, Jamie, was that RACF only, or was that part of the operating system?
It was RACF. It was RACF. So the ACE check was implemented on a RACF system.
Okay, so is that available on other security systems? Do you know?
That's a question, I guess, for the IBMers. Is it available for ACF2 or top secret?
I don't know. I guess we'd have to double check with them.
Yeah, I'm not sure, but yeah, this was a RACF system, Charles. So and it worked beautifully. So yeah, it doesn't take long to activate. By the way, it's not too much. But like I said, there's like Brian was talking about, the exceptions and things. You might have some programs that need to be added to the exceptions, but you'll figure it out. But it's just something that adds a value. And I know there's one or two people in the audience who are thinking about activating it, because I've been working with them. So yeah, just get it done. Right, so we're over time now. So thank you so much, Brian, for that. A lot of food for thought there, and certainly some new things for me to think about as well. So Brian's session is 8Q. There's the QR code there. Scan that with your smartphone if you want to be taken directly to the feedback link. You can do it through Bring Your Own Agenda as well, and also just go to the website and click on Brian's session on the agenda, and then you'll find the link down there. But please do it. And remember that the answer to question 2, the length of the presentation, 5 is the best answer, and the rest of them are weighted on. If you think the session was absolutely brilliant, and there's a 9, of course, is the higher score. So just keep that in mind. So Brian, thanks once again. Hopefully we'll see you again later in the year.
All right. Thanks, Jamie. Thanks, everybody.
No problem. And we're up at 4:30 UK time, by the way, in the security stream. So we've got Scott and his colleague that are coming to present to us on another topic, which you will be very interested in, about compromising system integrity. So please join us at that if you can. And of course, there are other sessions running. But with that, I will close the call. And thank you very much, everybody.